Hello, I am audible. Hello.
Yes, sir.
Okay.
Yes, sir.
Archana Yadav, do you want to present today?
Yes, sir.
Okay. Now start. Share the screen.
Okay, sir. Is my screen visible?
Yeah, yeah. Classification of memory.
Yes, sir. So,
Okay.
good afternoon, everyone. Today, myself, Ashna Yadav, is presenting on the topic classification of memory. So, first of all, what is memory? Memory is like we can refer it to a device or a place in a computer where we store our program or data for a time being or for permanently. It stores data in form of the electrical signal, or you can just say in it has various units in which it stores the data like bit and various other units. And the types of memory, there are various types of memory. There are basically three types of memory, that is primary memory, secondary memory, and cache memory. So they are further divided as that primary memory is divided into RAM and ROM, and they are also further divided. Then there goes the secondary memory, and secondary memory has the various types. Then primary memory we can refer it to the main memory or the internal memory, as the all of the things that is made by the manufacturer or the user about the system is stored here only, and it is boarded on the motherboard of the computer or of the CPU. And then primary memory is further divided into the RAM and ROM. There goes the RAM. The RAM, RAM stand for the random access memory. It stores the data on which we are currently working, and RAM needs the power for or electrical supply. We can say if when the electrical supply is cut off, the RAM loses all of the data, and the data that we are working, it's automatically erased. And then it is also boarded on the motherboard. It has a separate portion for itself on the motherboard, and it is also further divided into the static rom and the dynamic ram. And static ram and dynamic ram stands like static ram, it need to be refreshed, it doesn't need to be refreshed. It is faster and more expensive than the dynamic ram, whereas the dynamic ram is more volatile in nature and it need to be refreshed periodically. And ROM stand for the read-only memory. It refers to the place where we can just only read our data and the basic input or the output of the system. That is, it is called the BIOS of the system. It is non-volatile in nature. It means even if we lose the power supply or electrical supply, it doesn't loses its data. And then ROM is further divided into three parts, that PROM, or you can just call the PROM, and it refers to the programmable ROM. Programmable ROM, we doesn't have any right to change the data. It is manufactured by the company, but we can buy another disk of the separate PROM, and then we can just write our own data. Then comes the EEPROM, and it refers to the erasable type of the programmable ROM. We can erase our data. We use ultraviolet rays to erase our data. And then it goes the EE or EEPROM, you can call it. It goes for the electrically erasable free roam, and in which we erase our data using the electrical signals, unlike the ultraviolet rays. So it gives us an offer to erase data one by one or a bit by bit rather than erasing whole at a time. And secondary memory is like we store our personal data, or like we store our data and information, and we can access this to any time we want. And it is a fundamental memory of the computer. It is non-volatile in nature, like even if the power supply is cut off, we do not lose our data. And then it is there's various kind of types of the secondary memory, and it is categorized on the basis that how we approach to our data, like sequential or direct. And the sequential method, we go through our data line by line, and because it reads the data line by line, so we have to wait until our data to us or we reach to it. And then in the direct method, we can just directly reach to our information as we wish or as we want. And their examples are like sequential has the magnetic tape, and then direct has a magnetic disc or optical disc. Then magnetic tape is like a similar tape to a cassette disc, or like just we can just go through our data. It's coated with the magnetic core. We have to wait till we reach our data. It reads the data line by line, so we cannot find the exact location of our data. And then magnetic disk, like it's nowadays it's very popular because we can just go to our data when we want. We know the exact location of the data, and it's used for basically the information system and the operating system of our system. And it is also further divided into the hard disks and floppy disks, etc. And then goes the optical disc. Optical disc is where we store our data, and we use the optical disc to store our data optically. We use the light rays, and then it is stored in various forms. And it's flat and circular, and it's coated with the material which we can just. Optical disc is like very popular and small in size, and nowadays very popular because of its huge capacity, and we can read or write our data. And then it is also further divided into CDs and DVDs, that compact layer and digital versatile layer. Well, that was all from my side. Thank you.
Okay. Uh, Archana, which memory is the faster one, primary or secondary?
Sir, I primarily.
Primary. Why? Any
So
reason?
because right now we are working on that one, it's easier to like it's work on the current data we are working on.
What is DDR?
So what?
DDR. Have you heard about the DDR?
No, sir.
Okay. Have you heard about the SSD?
Sir, SSD refers to the.
Uh, because nowadays the memory which is pre-installed in your computer systems are in the form of SSD, which have the capacity up to the 1 terabyte like this. Okay.
Okay, sir.
Okay. Now open your camera. Archana, open your camera.
Sir, I'm trying to, but it needs permission,
Acha.
sir. Should I?
Okay, okay. Don't worry. Next one, the Anchal Kushwaha. Anchal Kushwaha,
Yes, yes, sir.
are, are you ready?
Yes, sir.
Okay, now start your presentation.
Hello, my name is Achal Kushwaha, and today good afternoon. And today I want to give my presentation on the topic history of computers. Um, History of computers. The first counting devices were used by primitive people. They didn't had any idea about any kind of
Beta,
calculating devices.
first, Archana, Anchal, just you share your screen,
So I've done that.
but not visible here.
So wait,
Uh, Again, try.
entire screen. So is it visible now?
No.
Yes.
Yeah, now it started.
Okay then.
Yeah, now
And
it's
history
working.
of computer. The first
Yeah,
counting devices were used by primitive people. They used bones, stones, and sticks in form of to do their calculations. And
good.
then abacus was introduced in about 4,000 years ago in China, and it was nothing. As you can see in the picture, it was nothing but a wooden rack with metal sticks and some beads. They used to count and calculate. It used to perform addition and subtraction only. And then in 1550, Sir John Napier introduced Napier's bone. It used nine different ivory strips of bones, which were marked with numbers to multiply and divide. So the tool was called Napier's bone. It was the first machine to use decimal points. Then in 1642, Sir Pascal introduced Pascaline. It was an arithmetic machine or adding machine, and he just invented this machine to help his father, who was a tax officer. And the you to use this machine, you have to rotate a wheel, and one rotation equals to one number. And then in 1673, Sir Leibniz, a German mathematician, improved the Pascal line and introduced his own Leibniz V. The speciality of this was he used fluted drums, and this machine was capable of multiplying and dividing also. And then the Charles Babbage, also known as the father of modern computer, in 1820 he introduced a difference engine. It was a steam driven calculating machine designed to solve tables of the numbers like logarithm tables. And then in 1830 the Charles Babbage introduced analytical engine, and it was capable of solving problems, and it has a permanent memory too. It used punch cards as input. Then in 1890, tabulating machine was invented by Hermann Hollerith, and was also a tabulator based on punch cards. And this machine was used in U.S. Census in 1980, and which later became the IBM International Business Machine in 1924. Then differential analyzer was introduced in United States in 1930. It was along the it used it was the first device to use vacuum tubes, and it can do 25 calculation in a few minutes. And the vacuum tubes were used to convert electrical signals to perform calculations. Then the major change of history of computer took place in 1973 when the Mark I computer was introduced. It was the first programmable digital computer, and then the generation of computers started. In each generation, the circuits become smaller and more advanced than the previous circuits, and which helped in improving the speed and reliability of the computers. Then the first generation of computers were very slow, use, and expensive. In this, vacuum tubes were used as basic CPU and memory. Basic components of CPU and memory, and this was based on batch operating system and punch cards. Magnetic tapes and paper tapes were used as output and input devices. Some of the popular first generation computers were ANIVAC, uh, ADVAC, UNIVAC, IBM 701, IBM 650. Second generation of computer was began in 1958 and lasted till 1965, and in this era transistors were used. And when we compare first generation and second generation computer were cheap, compact, and consumed less power. assembly level and programming assembly language pro, Assembly language and programming languages like COBOL and Fortran were used. It was a multi-programming operating system. Batch processing and multi-programming operating systems were used in this computer. And some of the popular second generation computer were IBM 616, 1620, IBM 7094, CDC 16404, and the third generation of computer started, which use IC. A single IC integrated circuits has a was a pack of huge number of transistors, and the which made them smaller, reliable, and they consumed less power. And also high level programming languages were introduced in this era, like Fortran second to 4, COBOL, Pascal, etc. And some of the popular third generation computers were IBM 360 series, Honeywell 6000 series, PDP, IBM 370 by 168, and the fourth generation computers. They used very large scale integrated circuits, VLSI, and were introduced in 1971. They were powerful, affordable, and fast. They were uh, they were the first to use as personal computers and used programming languages like C, C++, and database. And some of the popular fourth generation computers are DEC-10, Star 1000, PDP-11, etc. And the fifth generation was introduced in 1980 and it is lasted till now. They use ULSI, ultra large scale integration. It was made of they it is possible it made of possible the production of microprocessor chips with 10 trillion 10 million electronic components. And some of the popular fifth generation computers are desktop, laptop, notebook, etc. Thank you.
Okay, good answer.
Thank you, sir.
There is a one information for all presenter. Those students who have already presented their presentation, just send on my mail, writing their name and writing the presentation. Okay, in subject, write the presentation. This is the presentation, and okay, write your name. Okay, and send on my mail. That's why evaluation can be done. Okay. Next one is the Pranjal Gupta. Pranjal, are you here?
Yes, sir.
Okay. Are you ready to present?
Yes, yes, sir. Yes, sir.
Okay. Now you can start.
Sir, is my screen is visible?
Yeah.
Okay, sir.
Okay. Just
Hello.
make it little bit large.
Okay, sir. Sir, is this okay?
Okay. It's okay.
Thank you, sir. Hello, everyone. My name is Pranjal Rawat. I am here to present on topic implementation of ones and twos complement. So ones complement of a number means to interchange every zero bit with one and vice versa. In case of signed integers, ones complement of every number is represented by a binary equivalent of that number, while every negative number is represented by by its ones complement. In ones complement arithmetics, we can perform subtraction of binary number by using ones complement. To do so, we first find ones complement of number to be subtracted and then add it to the number from which it is to be subtracted. While if it results in any carry, then we shall add it to the least significant of the sum. There are examples on based on one's complement arithmetics. For example, subtract 1010 base 2 from 1101 base 2. To do so, we first find one's complement of 1010, which is 110101. Hence, the difference will be equal to the sum of the ones complement of 1010 and 1101, which is equal to 00011 base 2.
वन एज कॉम्प्लीमेंट कैसे हुआ बेटा, जरा चेक करिए।
Sorry, sir.
हाँ, वन एज कॉम्प्लीमेंट फर्स्ट का निकालिए, तो जो जीरो है वन कन्वर्ट हो जाएगा।
Yes, sir.
तो देखिए
Sir, ये
क्या लिख।
signed
हम्म
complement,
हम्म
signed one's complement. So it is a positive one, positive.
हाँ, वन एज कॉम्प्लीमेंट मीन्स पार्ट, जस्ट रिवर्स ऑफ द फर्स्ट वन ना।
यस सर, तो रिवर्स हमने उसको किया है, तो वो साइंड कॉम्प्लीमेंट उसका निगेटिव
अच्छा,
आया है।
अच्छा साइन था।
यस सर।
ओके, जस्ट चेक इट। ओके,
सर कैन आई प्रोसीड?
या
So now we have to add -9 to -8. The basic decimal solution for it will be -9 plus -8, which is equal to -17. For binary of 8 in bits, 8 bits representation, the binary equivalent will be 0, comma 000 1 000. Binary of -8 will be ones complement of binary 8. Negative, which is negative signed ones complement, which is equal to 1 comma 111 0 11. Hence the sum of binary -9 and binary -8 will be equal to uh, the sum of -9 and -8. For 2's complement, to get 2's complement of binary number, we add 1 to its uh,
वन
one's
एज
complement
कॉम्प्लीमेंट।
of the LS.
ओके,
Uh, in 2's complement arithmetic, we to subtract any two binary number by 2's complement, we first find the 2's complement of the binary number which is to be subtracted, and then we find the sum of 2's complement of the binary number and the number from which it is to be subtracted, carry. Then the result is the only sum part. The example for it is subtract 1101 with base 2 from 1011 base 2. Decimal subtraction will be 11 minus 13, which is equal to -2. One's complement of 1101 base 2 is equal to 0010, and two's complement will be addition of 0010 plus 1, which is equal to 0011 base 2. The difference is the addition of one's complement of two's complement of 1101 and 1011, which is equal to 1110 base. Thank you, sir.
ओके। Pranjal, open your video. Yes, tick. Okay. Now close it. Next one, Manvendra Pratap.
Yes, sir.
Okay, are you ready?
Yes, sir. Yes, sir.
Okay, now start your presentation.
So my screen is visible.
Yeah, just make some large, little bit large.
So now it's okay.
Now it's okay, but not visible. Yeah, now it's visible. Okay.
So good afternoon,
Now
sir.
it's
Good afternoon, everyone. The topic of my presentation is logic gates and its applications.
okay. Manvin,
Yes, sir.
there is one correction in my name. You have to write the Dr. S.P. Kanojia. Okay.
Okay, sir. Okay, sir. Okay,
And
sir. Sorry, sir.
the name of the Kanojia spelling is here Kanojia.
Okay, sir. I will
Okay.
correct it. Okay, sir.
Not Juia.
Okay, sir. Sorry, sir. So at the start of the slide, I have given the brief introduction of the logic gates. Logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. Based on this, logic gates are named as AND gate, OR gate, NOT gate, XOR gate, etc. Function of a logic gate is expressed using truth table. It displays all possible combination of the inputs and a column against each row shows the corresponding output value. Now let's discuss the types of logic gates. There are 7 types of logic gates. They are NOT gate, which is also called inverter, AND gate, which is also called multiplication gate, OR gate, addition gate, NAND gate, NOR gate, exclusive OR gate, and exclusive NOR gate. So NOT gate inverter. The output of NOT gate is high if the input is low and vice versa. Here is the Boolean expression of this NOT gate and this is the logic diagram and the tutor. It is the simplest gate of all the gates. It is the only gate which has one input. Except this, every gate has two inputs. It basically refers to as when the input is zero, we have to write just opposite of that in the output. If the input is zero, we have to write it one. If the input is one, we have to write it zero. So the next gate is AND gate. The output of AND gate is high if the both of the inputs are high and the output is low if both or either of the inputs is low. It's the symbol of AND gate. It's basically refers to it as AND gate. If both of the signals are, if both there is no signals in both of the gate, then the output is zero. If there is one signal, if there is signal in one of the output, then is the output is zero. Only if there is signal in both of the inputs, then only the output is one. OR gate, also called as addition gate. The output of OR gate is high if both the inputs are high or one of the input is high. The output is low if both the inputs are low. Here is the Boolean expression of OR gate, which is equal to x is equal to a plus b. It's the logic diagram of OR gate. It basically explains that if there is signal in any one of the expressions, that like if there is signal in A or B, then the output will always be 1. NAND gate. The output of NAND gate is high if both the inputs are low and if either of the inputs is low. The output is low if both the inputs are high. It's the symbol of NAND gate and it's the truth table of NAND gate. It's basically the opposite of AND gate. It is made with the combination of AND gate and the NOT gate. This circle here represents the NOT gate and its background body is called the AND gate. NOR gate. The output of NOR gate is high if both the inputs are low. The output is low if both the inputs are high or either of the inputs is high. It's the symbol of NOR gate and it's the opposite of OR gate. Again is made with the combination of NOT gate and OR gate. So whatever was the output of OR gate, here will be the just opposite of OR gate. Exclusive OR gate, the output of exclusive OR gate is high if either of the input is high. The output is low if both the inputs are low, high, or if both the inputs are low. Here is the symbol of XOR gate, and it's his truth table. It basically means that they if there is a signal, if basically one for the only one input, if there is input for only one in A or B, then only the output will be one. If there is, if the condition is same for both of the gates, then output will always be zero. Like here we can see that zero, if we, here in A or B it is written 0 and 0, then output is 0, like it's same. And 1 on 1, then it's 0. Baki except this, everywhere it's written 1. Exclusive NOR gate, the output of exclusive NOR gate is high if both the inputs are high, or if both the inputs are low. The output is low if either of the inputs is low. Here is the symbol of exclusive NOR gate. It's made with the combination of exclusive OR gate. In addition to it, we add the NOT gate. Then it becomes the exclusive NOR gate. So in the truth table it includes the value which are just opposite of the NOR gate, exclusive OR gate. There are some applications of logic gates. NAND gates can be used in burglars, alarms, and buzzers. They are basically used in circuits involving computation and processing. They are also used in push button switches, doorbell. They are also used in functioning of street lights. AND gates are used to enable or inhibit the data transmission. They are also used in TTL, transistor transition logic, and CMOS circuitry. So that was all about in my presentation. Thank you, sir. Thank you, everyone.
Okay, thank you. Just open your video. Okay, now close it. Okay, uh, next one, Ananya Singh. Ananya Singh, are you here?
Yes, sir.
Okay, are you ready to give presentation?
Sir, it would take some time. Wait, sir, I would represent it tomorrow.
Okay, what you have given the name previous day, na?
Sir, I
कल
included
आपने अपना
different.
नाम दिया था। ठीक है, ओके।
What, sir?
You have written your name.
Yes, sir. Yesterday I
Uh,
wrote.
yeah, I understand. Okay, no problem. Next one, last one, next one. Okay, okay. There is another Anu Prajapati. Here, Anu Prajapati. Okay. Any other student who want to present today? No. Okay. I am calling the your roll call. अंचल कुशवाहा, अंचल
Yes,
कुशवाहा,
sir.
आदित्य जायसवाल,
Present, sir.
आकाश वर्मा, okay. Do you want to present today? Okay, okay. अक्षत जायसवाल,
Present, sir.
ओके. आलोक भास्कर,
Yes, sir.
अनन्या सिंह, अर्चना यादव,
Present, sir.
अर्चना यादव, ठीक. नेक्स्ट अर्पिता सिंह,
Present, sir.
ओके. आस्था,
Present, sir.
आयुष कटियार,
Present, sir.
आयुष कुमार मिश्रा, आयुष कुमार मिश्रा, ओके. देन आयुष राय,
Present, sir.
ओके. हिमांशु यादव,
Present, sir.
Sir, Ayush Mishra also present, sir.
या हिमांशु कल आपने ज्वाइन नहीं किया था. कंचन सक्सेना,
Present, sir.
ओके. मानवेंद्र प्रताप,
Present,
ओके. मानवी कश्यप,
Present, sir.
ओके. मीनाक्षी शर्मा, मीनाक्षी शर्मा,
Present, sir.
ओके. निरंजन यादव,
Yes, sir.
आयुष, आयुष मिश्रा.
Yes, sir, present.
कल ज्वाइन नहीं किया था, कल और
No,
परसों.
sir, इससे
हाँ,
सर परसों था मैं सर कल नहीं था
19 को नहीं थे.
सर कल नहीं था सर परसों था मैं सर आपको मैंने कहा था सर दो आयुष एक्चुअली मिश्रा हैं यहाँ पे सर एक कुमार मिश्रा सर एक मैं मिश्रा हूँ सर
कुमार का तो लगा हुआ है. चलिए
सर मैं कल एब्सेंट था परसों नहीं
ठीक है. ओके. प्रगति मिश्रा,
Present, sir.
प्रगति प्रेजेंटेशन नहीं दे रहा है. क्यों तैयार नहीं किया? प्रांजल रावत,
Present, sir.
ओके. प्रिंस गौतम,
प्रेजेंट सर
ओके. रफी प्रभाधान,
Present, sir.
ओके. ऋषि श्रीवास्तव, नेक्स्ट. सचिन त्रिपाठी,
present, sir.
नेक्स्ट. शाश्वत मिश्रा, सावंत मिश्रा, सॉरी.
Present, sir.
ओके. नेक्स्ट शिवम खरवार,
Present, sir.
नेक्स्ट शिवम सिंह कुशवाहा,
Present, sir.
श्रेया अवस्थी,
Present, sir. Present, sir.
या ओके. श्रेया, यस. then Shubhi Kapoor,
Present, sir.
Siddharth Vajpayee,
Present, sir.
Srajan Srivastav,
Present, sir. Student Shasta present.
okay, Utkarsh Misra, sorry, उत्कर्ष मौर्य। उत्कर्ष आपका नाम नहीं है। वंश सक्सेना, वंश,
Present, sir.
विकास चौहान,
Present, sir.
ओके, विश्रुत,
Present, sir.
okay. Those students who have not given the presentation, prepare your presentation. Okay, next turn you have to give your own presentation. Okay,
Sir, मेरी attendance लगी ना?
सर नीरज
आपके
मिश्रा के
Sir, present
नी,
Shasta.
नीरज, let me check. नीरज मिश्रा, yes, okay. Next,
Sir, Ayush Kumar
Srajan
Mishra, sir.
Shasta.
Present.
yeah, आयुष हो गया. Next,
Srajan,
So, sir,
Srajan,
can I
sir.
ask,
Present
sir?
Shasta.
वंश हो गया.
Okay, sir.
सृजन श्रीवास्तव हो गया. Any other students who had not called their roll attendance? I think everyone got their attendance. Okay. Again, there is information for those students who have already presented their presentation. Kindly submit the presentation on my mail with your name and the subject title presentation in form of PPT. Okay. Now it's time to leave out. Thank you to all of you.
Thank you, sir.
Thank
you,
you,
sir.
sir.
Thank you, sir.
Okay.